What you have here is two unbiased, so means that unbiased means it's equally likely to fall in any of the 5 sectors. Spinners are labelled 1 to 5. An experiment consists of spinning them together, and the score is calculated by subtracting the smaller number from the larger number. When the numbers are equal, the score is 0. Complete the following sample space diagram show all the possible scores. So what I'm going to do first is, if I get 2 and a 2, what's the answer?
0.
Take the bigger score away from the smaller score? 0. If I get 3 and 3? 0. If I get 4 and 4? 0. 5 and 5? 0. Okay. A 1 and a 2? 2 and 1 gives me 1, because you take them away from each other. 3 minus 1? 2. 4 minus 1? And then 4. Okay. 2 minus 1? 1. 3 minus 2? 1. 2. You can see there's sort of a pattern here, can't you? There actually is a bit of a pattern here. So 3 minus 1? 2. 3 minus 2? 1. 1. 2. Next one. 4 minus 1? 3. 4 minus 3? 1. 0. 5 minus 4? 1. Next one. 5 minus 1? 4. 3. 2. 1. Okay. Is there any other questions I left out there in that one? So, next one is calculate the probability of a score of 0, guys. So how many scores is there in total? There's 5 scores from the first one, 5 scores from the second one, which makes a combination of 25 different combinations. Is there 25 different scores in this grid?
Yes.
Yeah, 5 by 5. So, what's your probability again of 0? How many zeros do we have? 5 out of? Which is 1/5. How many 5s do we have? None. So there's no total to 5. So 0 out of 5. 3 or more? 3 or more. Let's count. 1, 2, 3, 4, 5. So 5 out of 25, which is 1/5. Okay, so now I'm just going to get rid of what I did there a second ago. Consider the case where both spinners are relabeled with numbers 5, 6, 7, 8, 9. As before, the score is calculated by subtracting the smaller number from the larger number. Construct a sample space diagram, a two-way table showing all the possible scores. So, what they want me to do is they want me to reconstruct what I already had up here. Okay, so it's going to be 1, 2, 3, 4, 5, and then on this axis here 1, 2, 3, 4, and 5. I just have to relabel all the numbers. So what's a 5, 6, 7, 8, 9 now, is it? And then 5, 6, 7, 8, 9. Like last time, what's going to happen? Zeros on the main diagonal. 6 minus 5? 7 minus 5? Yes, 7 minus 5 is 2. 8 minus 5? 9 minus 5? Do you notice this turned out exactly the same way? If the next one turns out exactly the same way, I'm just going to write them all in the same. Okay, 6 minus 5? 7 minus 6? 8 minus 6? 2. 9 minus 6? What can we conclude now? It's exactly the same, okay? So it didn't actually matter. So what else can you conclude from this? If both of them are the same numbers, they're always going to make this pattern, aren't they? Any 5-sided spinner, no matter if they both have the same set of numbers, will always make this pattern that we're seeing here under the specific rules of this question. Okay. Calculate the probability again of 0. Why are we getting a 0, guys? 5, same as last time. The 5th, 5, 0, 3 or more, 1/5. By comparing the results in two-way tables for both experiments or otherwise, what conclusions can be drawn? Exactly what I said, they're the same. And if I change the numbers from 10 to 14 and both of them from 10 to 14 and did the exact same experiment, you'll get the exact same answer. Is that right? Okay guys, we're going to move on now. I might just do, I'll do number 6 because I think you guys will get the gist of this right away. A bag contains 5 discs numbered 1, 2, 3, 4 and 5. A disc is drawn from the bag and not replaced. Okay? Then a second disc is drawn from the bag. How many outcomes are possible?
Is the second disc replaced?
It isn't. It doesn't have to be replaced because when you take out, once you draw the second disc, the experiment's over. So you need combinations of 2. So we're gonna do a sample space. Now look at this, guys. Okay, you can't have the same disc twice. That's the one thing we've gotten from this, isn't it? Now, if there's 5 discs on the first draw, how many discs is there on the second draw? 4, because you're missing. There's 4 discs left, which will mean 20 different combinations, right? Now, what I'm going to do next is I'm going to do what's called a sample space, is what these things are called. And sample space. Is everybody paying attention, lads? You will need this. Okay. And so what we're going to do is we're going to draw numbers 1 to 5 on the top, 1, 2, 3, 4 and 5, and 1 to 5 on the bottom. What do we know has to be completely blank? You can't have 1, 1, you can't have 2, 2, 3, 3, 4, 4 or 5, 5. Why can I not have these ones?
0.
Sorry? 0. Not that they're 0. You can't draw the same token twice. See, the discs are numbered 1 to 5. You're not allowed to draw the same one twice because you don't replace it back in. Okay? So, we're looking to calculate the sums. So if we get a 1 and a 2, it's 3, 1 and a 3. You can see the pattern that's happening here. 2 and 1, 3, 2 and 3, 5, 6, 7. Next one, 4, 5, 7, 8. It says that, doesn't it? The sum of the outcomes. So it's in the language. The sum means add them together. Okay. The next one is 5.
How come you put lines in instead of zeros?
Because I'm not allowed to draw the same one twice. In the last question I was asked to take them away from each other, which is why I got a diagonal of zeros. In this one I'm told I can't have the same number twice. So taking a 1 out of the bag, the 1 is already out of the bag, so I can't pull another 1.
Yeah.
So if this blue region means it's a no-go zone, it just can't happen in this particular question.
The 0.
Sorry?
The 0.
No, this doesn't count as a result. In the last question, 0 counted as a result.
Yeah.
So this would have 25 results, but because I'm omitting 5 of them, it only has 20 results. Okay? So that's 7, 8 is gone, 9 is there, and then finally 6, 7, 8 and 9. Okay guys, we have 20 results here. Would everybody agree? 20 numbers? Now, find the sum of the outcomes is less than 5. How many of these are less than 5? Less than 5, so not including 5.
4.
1, 2, 3, 4. 4 out of 20, which is the 5th. One outcome is exactly 3 greater than the other. One outcome is exactly 3 greater than the other. What?
4.
Alright, so what this means, guys, is the combination has to be a difference of 3. So write down the combinations. 1 and 4 has a difference of 3. 2 and 5 has a difference of 3, yeah? 3, you can't get 3 and 6, can we? No. We can get 4 and 1 and 5 and 2. How many is that in total? 4.
So, 6 and 9.
Sorry. See, 6 and 9 is the total when you add them. This question is actually completely separated from part A. It says the outcome is exactly 3 greater than the other. So it's one outcome. My first score has to be one of the scores has to be 3 more than the other. So if I pull a 1 and then I pull a 4, that's okay because 4 is 3 greater than 1. If I pull a 2 followed by pulling a 5, that score is 3 greater than the 2. The opposite way around will work. I pull a 4 first and a 1 second. 4 is 3 greater than 1.
Yeah, 9 is greater than 6.
Yeah, but 9 is the total when you add them together. We're only adding them together for part A. See the way the part A says the sum of the outcomes.
When you add them together.
Sum of the outcome.
Here minus then the other 3.
Pretend this doesn't exist anymore. This was just to answer part A. Part B is completely separate to part A. Part B is basically the outcome is exactly 3 greater than the other. I'm interpreting that as the first token you take out is the first outcome, and the second token you take out is the second outcome. So that's why I put down these combinations here: 1 4, 2 5, 4 1, and 5 2. And that's 4 possible combinations out of 20, which is 1/5. Now the third question is completely different to A and B as well. You looking, guys? Yeah. So, Jordan. Okay, just focus in. Part C, the differences between the outcomes is 2. So the differences in the outcomes, this time I'm going to take the outcomes away from each other. Once again, these outcomes can't exist. Okay, so let's take our outcomes away from each other. 2 minus 1? 1. 3 minus 2? 1. 4 minus 2? 2. 5 minus 2? 3. So that's 1, 2, 3, 4. Next one. 2, 1, 1, 2. All these are the zeros, aren't they? So it's 3, 2, 1, 0, 1. And then 4, 3, 2, 1. I'm taking them away from each other as I did in question 2. Only for part C. It says the difference between the outcomes is 2. How many times do we get the number 2? 1, 2, 3, 4, 5, 6. 6 out of 20, which is 3 out of 10. What? Yeah. Find the expected score for the sum of 2 numbers drawn. What is the expected score? Expected score is going to be your average score. And it says for the sum. So that's when you add them together, right? Do you see the language? Find the expected score means the average score for the sum of 2 numbers drawn. You have to add them together. So I already did this earlier in the question, didn't I? Where I added them all together. So I'm just going to go all the way back to the part A I had. There it is there. Okay. Now, what we're looking to do here, guys, is we want to average. How many different values do we have here? We have 20 different combinations. Let's add all 20 numbers together. How many trees do I have? I have 2 trees. How many 4s do I have? 2 4s. How many 5s do I have? 4 5s. How many 6s do I have?
4.
And how many 7s do I have? 4. How many 9s do I have? Or sorry, 8s. And how many 9s? Now, what I have to do is I have to add all these together to get the total of everything added together, okay? So when you add all these up, I'm going to have 6 plus 8 plus 20 plus 24. Dennis, you paying attention? Plus 28 plus 16 plus 18. 120. 120 is your total of all. Anytime you have 20 different outcomes here, yeah? Does everybody agree with that? 20 different combinations of what you can do. You can have 1 2, you can have 1 3, you can have 1 4, you have 1 5. Okay? And what the question wants us to do is, out of all 20 outcomes, add them together and get the grand total of what all 20 outcomes would come to. Okay? Because they're all equally likely to happen. That's 120. 120 divided by all 20 outcomes gives you an average of 6. the expected score that you should come out with is a 6, because it should be 6 on average. Okay? Alright guys.